if an interstellar object whirling through our solar system is actually a nuclear-powered spacecraft sent by aliens to test how humans respond?
Something unprecedented just entered our solar system, and it's got scientists scrambling for answers. 3I Atlas, discovered on July 1st, 2025, is barreling through space at over 200,000 kilometers per hour on a trajectory that defies easy explanation.
On the 1st of July, NASA detected a mysterious object speeding toward Earth, and some actual bona fide experts think it might not be your typical space rock, or maybe any kind of rock, or a natural phenomenon at all.
This interstellar visitor is displaying behavior that's both familiar and deeply puzzling. While it shows signs of cometary activity with water ice signatures, its path through our solar system is so precisely aligned with planetary orbits that some researchers are questioning whether this could be natural at all.
The supposed comet is catching the attention of some of the nation's most renowned scientists, as one Harvard professor is raising the theory this may actually be a piece of alien technology.
Harvard's astrophysicist Avi Loeb, who previously suggested Oumuamua might be alien technology, has co-authored a provocative new paper asking whether 3I Atlas could be a disguised probe from another civilization.
With 0 meaning it's a natural object, like a comet, for sure, and 10 meaning it's definitely a technological object.
But here's the real kicker. New analysis suggests this object might be generating its own light, which would completely upend everything we think we know about its true size and nature. Subscribe to Space Aquarius and let's begin. Let's start with the basics of what we're dealing with here, because 3I Atlas represents something truly extraordinary in our cosmic neighborhood. The discovery happened thanks to the Asteroid Terrestrial Impact Last Alert System. That's what ATLAS stands for, operating out of Chile.
A new telescope built to track fast-moving space objects in Chile has caught a comet from beyond the solar system moving across the sky.
When astronomers first spotted this object, they immediately knew something was different. Its orbital eccentricity is well above 1, which means it's not gravitationally bound to our sun. This thing is just passing through, and it's doing so on one of the most extreme interstellar trajectories we've ever recorded. Now, here's where things get really interesting, and it involves a fundamental question about what we're actually looking at. The Hubble Space Telescope has been tracking this visitor, capturing detailed images that reveal a distinctive glow pattern. What scientists discovered is that this glow has an unusually steep brightness profile, much steeper than what we typically see in solar system comets. This brightness pattern is raising some profound questions. You see, when we estimate the size of objects in space, we usually assume they're simply reflecting sunlight. Using this standard model, 3I Atlas would need to be roughly 20 kilometers in diameter to produce the brightness we're observing. That would make it absolutely massive, potentially 40 times larger than our previous interstellar visitors like Oumuamua and 2I/Borisov. But here's where Avi Loeb and his colleague Eric Keto have made a startling observation. The brightness profile they're seeing is consistent with something completely different, an object that's producing its own illumination rather than just reflecting light from the sun. Think about the implications of this for a moment. If 3I Atlas is actually self-luminous, then it could be dramatically smaller than we initially calculated. We're talking about the difference between a 20-kilometer behemoth and something potentially just hundreds of meters across. That's not just a minor adjustment, it's a complete paradigm shift in how we understand this object. And here's why this matters so much. The statistical probability of finding a genuine 20-kilometer interstellar asteroid is virtually 0. Loeb's calculations show that the limited reservoir of rocky material drifting between the stars could only deliver such a massive object to our solar system perhaps once every 10,000 years or longer. The universe simply doesn't have enough large rocks floating around in interstellar space to make frequent visits plausible, but a smaller self-illuminating object? That changes everything about the probability calculations and opens up possibilities that are frankly mind-bending. So what could cause an object to generate its own light? There are several possibilities, and not all of them are natural. Radioactive decay from heavy elements could produce a glow, though finding enough radioactive material in interstellar space would be extremely unlikely. Thermal emission from internal heat sources is another option, but that would require the object to maintain temperatures well above what we'd expect from solar heating alone. Or, and this is where things get really intriguing, we could be looking at artificial illumination from some kind of technology. The spectroscopic observations from Gemini South and the NASA Infrared Telescope facility have revealed strong water ice signatures mixed with carbonaceous minerals and silicates. The water ice shows characteristics suggesting it could be chemically pristine, lacking the heavy isotopic signatures we typically see in solar system comets. This water could have formed billions of years ago in a completely different stellar environment, giving us a direct window into how planetary systems form elsewhere in the galaxy. But even this cometary evidence doesn't settle the debate. In fact, it might support the artificial hypothesis in an unexpected way. If 3I Atlas is indeed some kind of probe or spacecraft, the dust and ice we're observing could simply be accumulated material from its long journey through interstellar space. Cosmic debris that's built up on its surface over millions or billions of years of travel. Now let's talk about that trajectory, because this is where the evidence for something unusual really starts to pile up. In their paper, Is the Interstellar Object 3I Atlas Alien Technology? Loeb and his collaborators present statistical analysis that's genuinely unsettling. 3I Atlas is traveling on a retrograde orbit that's tilted only about 5 degrees from the ecliptic plane, where Earth and most planets orbit. The probability of this happening by random chance? They calculated at roughly 0.2%. But it gets more intriguing when you look at the planetary encounters. This object is going to make remarkably close approaches to multiple planets. It'll pass within about 29 million kilometers of Mars on October 3rd, reach perihelion at 1.35 astronomical units on October 29th, and later swing within 33 million kilometers of Jupiter. The combined probability of a random interstellar object making such close approaches to 3 major planets? Approximately 0.005%. That's 1 in 20,000 odds. Here's another detail that's raising eyebrows. I-Atlas reaches its closest approach to the Sun when Earth is on the opposite side of our star. We literally won't be able to observe it during this critical phase. If you were designing a spacecraft to conduct operations while avoiding scrutiny from Earth-based telescopes, this timing would be absolutely perfect. Loeb calls this a potential reverse solar Oberth maneuver, a high-thrust braking strategy that could allow an interstellar craft to slow down and potentially remain in our solar system. The fact that this maneuver would be completely hidden from Earth's view by solar glare is either an incredible coincidence or evidence of deliberate planning. But let's be clear about the scientific consensus. The majority of astronomers studying 3I Atlas believe it's a natural interstellar comet, and they have good reasons for this position. David Jewett from UCLA, who's been analyzing the Hubble data, points out that 3I Atlas is displaying classic signatures of cometary behavior. The dust production rate they've measured, between 6 and 60 kilograms per second, falls within expected ranges for comet activity. The ejection velocities of 20 to 2,000 meters per second also match what we see in normal comets. Moreover, the fact that we haven't yet detected volatile gases like cyanogen or diatomic carbon isn't unusual. 3I Atlas is still about 4 astronomical units from the Sun, roughly Jupiter's distance. Most comets don't start showing strong gas emissions until they get much closer, and solar heating really intensifies. The self-illumination hypothesis also faces challenges. If 3I Atlas were generating its own light through some kind of nuclear process, it would need to produce roughly 10 gigawatts of power. That's equivalent to several large power plants. Maintaining that kind of energy output over the millions of years of interstellar travel would require either an enormous fuel supply or technology far beyond our current understanding. The next few months represent a critical observation window. As 3I Atlas approaches the Sun, we should start seeing those telltale gas emissions if it's truly a comet. The James Webb Space Telescope has this object in its sights, and its infrared capabilities could reveal unprecedented details about its temperature profile and energy output. There's also an exciting possibility involving Mars-based observations. When 3I Atlas passes close to Mars in early October, there's talk of using the HiRISE camera on the Mars Reconnaissance Orbiter to capture high-resolution images. This could give us our best close-up look at an interstellar object's surface, and potentially resolve the question of whether we're seeing reflected sunlight or self-generated illumination. But here's what really has me excited about the future. The Vera C. Rubin Observatory has just begun operations. This revolutionary facility will detect dozens of interstellar objects annually, giving us the statistical sample we need to understand what's normal and what's truly anomalous. Consider the implications if the self-illumination hypothesis proves correct. We'd be looking at an object that's not only artificially lit, but also following a precisely calculated trajectory through our solar system. That would represent the most significant discovery in human history. Proof of visitation by another civilization. Even if 3I Atlas turns out to be completely natural, the brightness profile mystery is teaching us that interstellar objects can behave in ways we never expected. Whether it's exotic physics we don't understand or technology we can't yet imagine, this visitor is expanding our conception of what's possible in the cosmos. So where does this leave us? iAtlas continues its journey through our solar system. We're witnessing real-time science at its most exciting, with fundamental questions about the nature of this object still hanging in the balance. The self-illumination mystery adds a completely new dimension to this story. Whether we're looking at exotic natural processes or something far more extraordinary, evidence of artificial technology, the next few months will be crucial for understanding what 3I Atlas really represents. October's close approach to Mars, the hidden perihelion passage, and December's Earth flyby will provide unprecedented opportunities to solve this cosmic puzzle. With each observation, we're getting closer to answering not just what 3I Atlas is, but what it means for our understanding of intelligence and technology in the universe. The universe is vast, full of mysteries, and 3I Atlas is proving that we're only beginning to understand what's possible out there. Whether it's a natural wonder or something far more profound, this visitor is reminding us that the cosmos still holds secrets that could change everything we think we know about our place in the galaxy. Craving the latest news about our galaxy and the universe? Subscribe now and stay ahead of the discoveries.